Welcome, students. Welcome to the fifth edition of Lead Masterclass. This is your host for the day, Himanshu. At Lead, we ensure that our students should not only be equipped with excellent academic education, but also with skills that help them to succeed in life. Before we begin, please make sure that you tell us how excited you feel about today's masterclass in the comment box. Do drop in your name, school, and which city you belong to in the comment box. Now, maths can be fun too if students can relate it to real life and are taught in a very fun way. To remove the fear of math in students, we are presenting a lead masterclass on mental maths. Our instructor for the day, Mr. Debapriyay Mukhopadhyay, has founded the blog Ganit Charcha. He and his team work in popularizing mathematics amongst young school students. He has been a corporate professional for the last 20 years and is currently associated with Vehere as a senior product manager. He is working in developing solutions for cyber defense. Sounds exciting, right? Now, kids, without any further delay, let's hear it from Mr. Debapriya. Deb, you will have to unmute your mic, please.
Hello everyone, good morning. I would like to thank Himanshu for this nice introduction of mine. And also I would like to thank Lead for providing me with this opportunity to interact with you all. So before I start, so I would like to say a few things on mathematics in general. So basically, why do we require to learn skills of mental maths? It's not only because of being able to relate it to some applications in real life. It has got immense uh, applicability to in your confidence building, in your ability to perform well in competitive examinations, different entrance examinations. uh, it would help you in future. If you learn something today, it could help you 10 years back down the line, while probably you will be preparing for some civil services examination or preparing for some other top-notch government organizations. Mathematics is a must, and 10th standard mathematics is a must in most of the examinations. And there, in limited amount of time, you need to do lots of mathematics. You need to solve 100 or 200 problems. Not all problems are basically of descriptive type. Basically, they are of very aptitude test type nature or very short type nature, tricky questions. So if you have given time, probably you could do all the things, but you are given a very short time. Basically, that's where the challenge lies. So mental math skills or uh, thinking out of the box, basically, which I can call as strategies to solve different problems, can help you in cracking these examination very easily. You need practice, of course. You need practice. You need to have the concept ready. You need to know the concept. Without them, you cannot apply. So you, even on top of that, if you know different strategies to attack different kinds of problems, there are different ways you can solve a single problem. Now, which problem can be solved in shortest possible time, that could possibly take you to the right direction of cracking these exams. Or in order to be able to do that, you need to have the right set of tools or mental math skills in hand. uh, so this is very important. So what you learn today maybe will not be readily applicable in your day-to-day life, maybe will not be readily applicable in tomorrow's examination, but maybe it will be applicable days after, maybe 10 years down the line. So with that, I will start. So you all know numbers. uh, you have already gone through basic operations on numbers. You have learned to count, you have learned to compare, you have learned to do addition, multiplication, division. You have learned to do many other things with numbers, basically descending, ascending order. You have learned to find out greatest number. Maybe you have learned to find out HCF, LCM of two numbers, or so there are different things you can do with numbers. You have learned many concepts with numbers. But what I will start with, basically, there is a general fear about mathematics. Basically, people tend to feel not comfortable with mathematics. There are reasons behind that. That topics are introduced in a discrete way. Topics are not introduced in a continuous fashion. Say, for example, you learn concept number one first, and then concept number two, and then concept number three, and why concept number two is learned after concept number one, or why concept number three is being learned after concept number two, and what is the thread between these, all these concepts. So these things are basically not told. So since they are not told explicitly, so people starts to think in a way that you have to remember how to do HCF, you have to remember how to do addition, you have to remember how to do multiplication, you have to remember how to do division, you have to remember different multiplication tables and all. But it's not like that. Basically, you have to remember, basically because you need to deliver these things when you have to appear in some examinations. But other than that, you can devise these schemes from the need. You can devise these uh, different tools from the scratch of your basic understanding. And why these schemes are required and why these things are required, you need to understand that very well. So I'm not going into the details of all these things, but rather I will start with some beauty in numbers. Basically, numbers are very beautiful. One of the famous mathematician, Paul Eddowes, was once asked that why are numbers beautiful. So he told, it's like asking why Beethoven's Ninth Symphony is beautiful. No one can tell you why numbers are beautiful. You have to appreciate it. You have to appreciate it yourself, that why numbers are beautiful. And he ends up saying that if numbers are not beautiful, then nothing is. So that's what his answer was. So in line with that, I will start with some beautiful things which probably you have missed out when you have learned these numbers. So let's start with that. So you see here 19, 29, and then 39, 49, 59, 69, and 79 and 89 are expressed as sum of the digits and then product of the two digits, and then adding these two things. So 19, basically you sum up 1 and 9, that is 10, and then you multiply 1 and 9, that is 9. So 10 plus 9 is equal to 19. Then you see 29, it's again the same thing. Add the two digits, 2 plus 9, so it's 11, and then you add 2 into 9, it's 18. So 18 plus 11 is 29. And then you do the same thing for other numbers too. So 39, 3 plus 9 plus 3 into 9, 49, 4 plus 9 into 4 into 9. And everywhere this identity remains same and these pattern remain same. I would like to ask that whenever you are learning these numbers, have you ever looked into these numbers in this way? Probably not. But this is where the beauty lies. So you have to culture, you have to work with numbers. You have to think about numbers. You have to think in terms of numbers to see the beauty. Now I would like to ask you that what about 99? Does it follow in the same, will it follow the same pattern? What about 109? Will it follow the same pattern?
Right. So students, very interesting question. So what you see, the pattern that you see in front of you, Mr. Debapriyay is asking, will 99 and 109 follow the same pattern? Uh, so Ankita Kripa is saying, yes, it will. 99 follows the same pattern. Yeah, right, students. So we're waiting for more answers. Kavita is saying yes. Saburi is saying yes. So yeah, we have Ajit. A lot of students are typing in yes.
Yes, right. 99 also follows the same pattern. What about 109? We'll see in the next slide. So there is a bit of catch in 109. So 109 can also be expressed like this, but it's not the sum of the digits. Up to 99, it was sum of the digits and product of the digits, and then the two things added together. But from 109 onwards, the similar sort of expression remains valid, but it's not the sum of the digits, because 109, if I do the sum of the digits, it will merely be 10. But here, what I have written it as, you take the first two, so consider it a single number, so 10, then plus 9, just leave aside 9 like other numbers for other numbers, and then do the same uh, for the product also. So 10 into 9. So 10 plus 9 is 19, and 10 into 9 is 90. So 90 plus 19 is 109. Now I would like to ask you to figure out what about 119. Will a
Yeah, so
similar sort of expression for 109 hold for 119?
yeah, so Alka, Bhavne, Devsa, Kalyani, Vaishnav, everyone saying yes here. Loken, Tanvi, Sagar, Janvi, so everyone saying yes here.
Yes, right. So for 11, 119, 11 plus 9 plus 11 into 9 also holds. So I have said up to this. Now just think about this. You have a lot of things to do in your home. So you can try with 129, you can try till 199, and then you can think about 209, 219, 309, 319, and see that whether this pattern holds or not. When this pattern starts to deviate, ask yourself the question that why this pattern works. Ask yourself the question that from where this pattern doesn't work out. What about 18? What about 48? Whether these type of pattern can be generated for these numbers or not. Are there any other numbers for which this type of pattern holds? Are there any other ways of writing patterns for other numbers? Here it is plus, then multiplication, and the two things put together. Maybe some other expression will hold for other numbers. So ask yourself these questions. You have long learned to count. You have long learned to add, multiply. So whenever you have free time, whenever you have 30 minutes time to spend in your leisure, take these questions in your leisure. Take these type of challenges. Challenge yourself with these questions. You will see the beauty. You will automatically get fascinated with numbers, and you will automatically get inclined to mathematics. So there are plenty of food for you to think. Just in these two slides, there are plenty of food for you to think and you to spend time, hours. So just think about it and do your due diligence in figuring out other numbers, figuring out other patterns, and figuring out the same pattern for other numbers, and figuring out other questions like when this will not be valid anymore. Now I will move on to the next slide. So here I have taken three numbers: 47, 497, 4997. What is special about these numbers? If you see, if you add 2 with 47, it will give you 49. If you multiply 2 with 47, you will get 94. Now you see 49 and 94 are reverse of each other. The same thing holds for 497. You see 497 plus 2 is 499. And 497 into 2 is 994. Again, the reverse of each other. 4997 plus 2 is equal to 4999. And 4997 into 2 is 9994. So reverse of each other. So addition with 2 and multiplication by 2 gives rise numbers which are reverse of each other. Now I will ask that is there any other number? Can you think about any other number which is having the same property?
Yeah, students, do you want to give it a shot? Very, very interesting property that Mr. Dev shared. So what you see in front of you is, 47, 497, and 4997. They have a very special property which is shown on the screen. Do you think if there's any other number? All right. So, Mr. Debapriyay, just for your reference, there are like hundreds of students, typing in their comment box. A lot of students are still sort of quizzing each other on the previous uh, sort of numbers that you talked about. Jarnail is saying 100 plus 20 minus 1. Sadi is saying 509. Okay. So we have a lot of responses coming in. Arnav, Anushka, a lot of people are saying 509. Dharmendra is saying 4997. Shantanu is also
Yes,
saying
4997 is the next number in this sequence. 509 is not true. 509 plus 2 is 511. And
yeah. So Kavita,
509
Ramesh,
into
uh,
2 ends with 8. So 4997 is the next number in the sequence. And then again, four nines consecutively, and then followed by 7 is the next number in the sequence. So any number of nines, if you put between 4 and 7, will have this property. Any number of nines. So it's not just these two numbers is having these special property. So you have to start with 4, and then you can write any number of nines in series, and then you have to end the number with 7. These will have the similar property. So it's an interesting sequence. And so far, I have not been able to figure out any other number other than one special case, which is having these property. So I will now talk about this special case, which doesn't start with 4, which doesn't end with 7, and which doesn't have any 9. So that number is 2. So 2 plus 2 is equal to 4, and 2 into 2 is equal to 4. Since it's a single digit, so I can still say that both reverse of one digit is the other, because 4, if I read it from left side or right side, it's the same 4. So 2 is also having a similar type of property. So other than 2, 47, 497, 4997, and the way we can go ahead. So 4, any number of nines, and then at the end 7. There are no numbers I have been able to figure out which is having this property. So I think you also feel this is beautiful. So this is where the beauty in number lies, and you should start working on these sort of things. You should start think about in these lines at your leisure to feel the beauty, and you will automatically get attracted to the subject mathematics. You don't need to feel bogged down, or you need to feel fear about the subject. So this is why I have put these two things, or these two beautiful things about numbers to start with. Now I will enter into the main theme of today's presentation. So I have already talked about this. It's really important, and you have already got to know many things about its application uh, in grocery shop, to efficiently plan your spends while buying. You do calculations mentally. In sports, you tune your strategy, you tune your timing, you how to score, and how you can plan to cover up a particular run within a fixed set of overs. All these things comes under the purview of your mental maths. You automatically do while you in action, so you don't need to have pen and paper to work it out. So you compute it mentally, and you apply it, you apply your thoughts. So the region where you can apply it is vast. Also, I have told to you that to score better in exams, you also should know mental math strategies, because that will save your time, that will help you to crack competitive exams too. Having said that, I will now move on to the tricks. So I have a few set of multiplication tricks that I will talk about. So you have you know about multiplication, and you have already know that how to do multiplication. You also have learned about multiplication tables and all. Now you mostly have started remembering multiplication tables. That's fine, because you anyway need to remember multiplication tables, because that will save time in your examination. But apart from that, you can devise multiplication tables whenever you think that you don't remember it. uh, so it's not a big deal. You don't need to feel bad that you don't remember what is 16 into 5 is, or 16 into 7 is. So you have to just spend a bit of time to figure it out. So I will show that how all these things you can figure out. Now I will start with this a simple thing. So what I have written here is, on the left side column, I have written from 0 to 9 in ascending order. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And on the right hand side column, basically I have written the same set of digits on the reverse order. So 9 at the top, and then in descending order, I'm writing it 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. Now this is basically, now if I see this is nothing but table of 9. You have written down table of 9. If you consider these two digits that you have written down first as a number. So 09 is 9, so that's 9 into 1. Then 1 into 8, 8 is basically 9 into 2, 18. 2 7 is 27, that's 9 into 3. 3 6 is 36, which is 9 into 4. And so is the case for 81. So that is 9 into 9. And lastly, you have written 9 and 0, that is 90, which is 9 into 10. 10. So this is simple table of 9. So you have remembered it, we have also remembered it while we are studying, while we are student. But everything has a different way of looking at it, so you can take a look at it in this way as well. And there are plenty of other things also, for which you will see examples, you will see scopes where you can start looking into things in different angles. Now I will that is not in the slide, but I will talk about it. Uh, so what about 11? So you know the table of 11, say up to 9, or maybe up to 10, or maybe even up to 20. So 11 9 is 99, 11 10 is 110, and 11 11 is 121, 11 12 is 132, and so on. Now, have you ever thought, or have you ever taken a look into the multiplication table of 11 in greater detail? So does it show any pattern to you? If you take a look at it in a greater detail, you will see that there is a pattern involved in the table of 11, particularly when it is being multiplied with 2 digits. So if you see 11 into 11, so that's 121. So the first digit still remains the same, 1, and the last digit still remains the same, that is 1, and the middle digit is 2. So middle digit is nothing but 1 plus 1. Now, if you see 11 into 12, that is 132. So you see the first digit is 1, and the last digit is 2. Basically, you are multiplying it by 12. So the ones place is 2. So that gets into your result, and you are multiplying it by 12. So if you sum total the 2 digits, if you take the sum of the 2 digits, 1 plus 2, so that's basically 3. So that's your 132. The same thing holds if you multiply it with 11 into 13. So what about it? It's 143, right? So you are multiplying it with 13. So 3 comes in the ones position, and 1 remains in the first position. And then since you are multiplying with 13, so it becomes 1 plus 3, which is 4, that takes place of the tens position, 143. What about 11 into 14? Does it follow the same pattern?
The student, very, very interesting again. 11 into 4, does it follow the same pattern? Do you want to guess what the number will be using the same pattern that Mr. Debapriyay was talking about? Please type in your responses in the comment box. Yeah, so we have responses coming in. All right, so there's Rohit, Ashi. A lot of them are saying yes, it will follow the same pattern. Aryan is saying, nice trick, sir. This is I'm from Golden Valley Public School. I'll never forget this trick. Sarthak is saying, great, thank you so much. So I think this is a very, very helpful trick. But yeah, a lot of students are saying yes, it will follow the same pattern.
Yes, it will follow the same pattern, but there are exceptions. So now let me tell you the exceptions. Now 11 is being multiplied by a 2-digit number. This trick will work seamlessly when the sum of the digits of the other number, which is not 11, is less than equal to 9. Until then, this trick works. So if you say, for example, if you take 18 into 11, the same trick will apply, same formula will apply. So it will be 18 into 11. So 8 will be at the ones position. Then in 10th position, you have 1 plus 8, that is 9. And in the 100th position, it will be 1. So it will be 198. But the moment you will start to multiply it with 19, it will not work. So 19 into 11, this trick will not work. Why? Because 1 plus 9, 1 plus 9 is no more a single digit number. It's a 2-digit number. It's a 2-digit number. So what you have to do? So that since you have got the 2-digit number, so you have to the carry that I am talking about. So 1, that is 1 basically. So that 1 you need to add with the first number. If you would not have the carry, then what would have been your first number? You have to add 1 with that. and the number that you are getting in the ones position after adding, that should remain in the middle, and the last number remains the same. So that's basically the ones digit of the other number with which you are multiplying 11. So take the example 19 into 11. So 1 plus 9 is equal to 10. So your first number will be 1 plus 1, 2. And since 1 plus 9 is equal to 10, so 0 is the ones position. So 0 will be in the tens position in the resulting multiplication result. So 2, 0. And you are multiplying by 19. So 9 will be at the end. So 209. So the answer will be 209. The same way you can do it for other numbers too. For example, if you multiply 11 with 21, it falls under the first category where you don't have any carry. So the same thing applies again. But when you multiply 11 with 86, so you see now 86 is giving a carry 14. So if you would not have that carry, you would have written 8 at the 100 position. So instead of 8, you will write 8 plus 1, 9. And since 8 plus 6 is 14, so 4 is the ones place, so that will take the tens position. So 9, 4. And you are multiplying it with 86, so 6 is the ones position. So it will be 9, 4, 6. So this will be the result when you will multiply 86 with 11. And these can help you multiply 11 with any two-digit number. So remember this trick. This trick will be of immense use and you can readily apply it in any context. We'll see that how you have been able to understand this at the end of this session. So now I will move on to the next thing. So basically you have forgotten the table of 13. So what will you do? So you don't remember. So it's easy. You have to first write the table of 10. So you first write the table of 10 and then you write the table of 3. So table of 10 is 10 into 1 and table of 3 says 3 into 1. So 10 plus 3 is 13. Then for 13 into 2, table of 10 says 10 into 2 is 20. And then you do 3 into 2, which is table of 3. So that is 6. So 20 plus 6 is equal to 26. So that's your 13 into 2. Then 13 into 3. So that's basically you have to write first 10 into 3 and then followed by 3 into 3. So that's 30 plus 9 is equal to 39. And then 13 4 into 4. So you have to write first 10 into 4, then followed by 3 into 4. So 10 into 4 is 40 and 3 into 4 is 12. So 40 plus 12 is 52. So you can come up with the whole table of 13 without even remembering the table of 13. You know table up to only 10. So you have written down table of 10 and you will know table of 3. You just write down the table of 3 and just sum total of these elements of these two tables and you will get the table of 13. You can see it in the slide as well, whatever I have just explained. Yeah. So this is how it is. So 10 into 1 plus 3 into 1 is 13. 10 into 2 plus 3 into 2 is 26. 10 into 3 plus 3 into 3 is equal to 39. So if you take a closer look into this is not very difficult to think. Why? Because if you take a look into 13 and if you express it or if you expand it in place value system, that will basically will give you 10 plus 3, right? So 10 plus 3 is the expansion of 13 in the place value system. Now that 10 you are multiplying with 5, and that 3 you are multiplying with 5, and that is what is helping you to write the table of 13. Now I will ask a simple question to you. What about 17 into 7? Say for example you don't remember it. So what is the thing that you will do to compute 17 into 7?
Yeah, students. So the question is, using the same pattern, can you compute 17 into 7? A very,
I
very
don't want
interesting
to
pattern.
know the answer. I just wanted to know that suppose you have forgotten the table of 17. So what is the thing that you will do to come up with 17 into 7? So what you compute first and what you compute next and what you add together to find out 17 into 7.
Right, students. So can you please, yeah, put in the comment box like how you will compute 17 into 7? Right. So there is Jarnail, Ajit, a lot of people are saying you'll do 10 into 7 and then you will do 7 into 7. There
Yeah,
is
that's right.
Mamta. So a lot of students are saying the same now.
Yeah, that's
Nafisuddin
right.
saying, yeah, yeah, same thing, yeah.
Now my question is, this is about creating a table. What about expanding this scheme to any number, any digit? So instead of 13, I could have 1, 2, 3, 4, 5, 6, 7, and then I have to multiply it with 7 or multiply it with 8. So these scheme place value scheme can be extended for that too, which we will see in the next slide. Yeah. So here it is 37 into 5. You will rarely be asked the table of 37, right? You will rarely be asked table of 37. Nobody will expect from you that you will remember table of 37. But the strategy simply can be extended for this too. So 37 in place value system will be 30 plus 7. So the same thing that you have done for 17, you can do it for 37 also. So you have to multiply 30 with 5, and then you have to multiply 7 with 5. So 30 into 5 is giving you 150, and 7 into 5 is giving you 35. And then you take add these two numbers, 150 and 35. So that's your 185. So that's a simple example because you are being asked to multiply 37 with 5. It could be 3721 into 5. So you take the same strategy. If it is 3721, then it will be 3000 plus 700 plus 20 plus 1. And you multiply each of these numbers with 5. So you multiply first 3000 with 5, that's your 15,000. You then multiply 700 with 5, that is your 35,000. It's 3,500. Then 2 1, so 20 into 5, that's your 100. And then 1 into 5, that's your 5. So you add these numbers, these four numbers. Here you are adding two numbers, there you have to add four numbers, and it will give you the value of 3721 into 5. The more you practice, you can automatically, for 3-digit, 4-digit numbers, you can automatically calculate this in your head. You don't need to sit with pen and paper to find out the result. So that's where the beauty lies. So you have to practice more. Apparently it seems that you have to compute, you have to do the addition, but when you practice more, it will not be that difficult to have a running sum. Say for example 3000 plus 5, that is your 15,000, and then you have 700 plus into 5, that's your 700 into 5 is 3,500. So 15,000 plus 3,500 is 18,500, and then you have 2 into 5, that is your 100 again. So 18,500 plus 100, 18,600. And then lastly, you have 1. So 1 into 5 is 5. So 18,605. So that's the the result of multiplying 3721 with 5. You don't need to have a pen and paper. So you have to practice more to be able to do it efficiently in your head, and that will save you time. Now I'll go move on to the next slide. So whatever I have just told, so this is an example for that. So 234 into 7. So 234 is equal to 200 plus 30 plus 4, and you do the same thing for each of these numbers: 200 into 7, 30 into 7, 4 into 7, and that is giving you the result 1638. Now, if I ask you to multiply 513 with 6, what will be the result? I want the first answer.
Right. So students, the question is multiplying 513 with 6 using the same expansion method that is right there on the screen that Mr. Debapriyay just told you. So 513 multiplied by 6. Let's see who's able to get the right answer first. But please do this, use this method only, because we're sure if you use this method, you will be able to calculate even faster than a calculator, right? So all right. So Anvita is saying 1638. Saburi is saying 16.
513 into 6. 513 into 6. So 500 into 6
Okay. So there
becomes
is
3000.
Kavita. Yeah, yeah. So Balaji, Kavita, they're saying 3076. 513 into 6. All right, students, please keep typing in your answers. Kavita is saying 3457. Subhash is saying 3078. Balaji is saying 3078. Shrinkichal is saying 3078.
Yeah, now verify your result by doing standard way of multiplying, which you already know, and you automatically will be able to understand that whether you have done it correctly or not. But you have to do it more and more to be able to really appreciate it and do it quickly. Now I will move on to the next slide. So that's basically 15 trick. So it's simple. So first you multiply by 10 and then add half of it. So it's the other way of stating whatever I have said earlier. So 15 is 10 plus 5. So you first write the table of 10, and then you write the table of 5, and then you add the two numbers. But here what I am stating that you even don't need to do the multiplication by 5. You have already computed the table of 10. So you just take half of it. So that's even easier. So that's what is being told here. So 15 into 18. So 10 into 18 is 180. And then you could have done 5 into 18. So that's basically 90. So instead of doing that, you can just do 180 divided by 2, because 5 is simply 10 divided by 2 is 5. So that's what I'm doing here, 180 divided by 2. So only one number I am computing. So that's 10 into 18. And then I'm taking half of it. That's 90. And since I'm multiplying with 10, so obviously the last number that I have in the multiplication is ending with 0. That means once digit is always 0. 10 into 18 is 180 always. It could have been, if it would have been 17, it would have been 170. So since the last digit is 0, and multiplying it, dividing it by 2 is not that difficult. So 180 divided by 2 is 90. Now you just take the sum of these two numbers. So that will give you 270. Same thing for 15 into 33. So what you do, you first multiply with 10. So 33 into 10 is 330. And you can simply half of it. So 33 divided by 2, which is 165. So then you take the sum of these two, 33 plus 165, and that gives you 495. So basically the same thing, but it is being put in some other way. So the different ways of taking a look into the same problem. Uh, Someone might have been very successful in dividing a even number with 2 very quickly. So for him, it will be of great help. And who is comfortable in multiplying the number 18 or number 33 with 5, he could have done the other way, basically without dividing by 2. So whatever applies to best for you, you have to choose that. So whatever suits you best, you have to apply that strategy. But the bottom line is the same, that you have to think about taking a look into the same problem from different angles. You have to think about looking into the same thing from different sides. Then automatically different strategies, different ways of thought, different ways of looking into a particular problem, different ways of solving a particular problem will automatically come into your mind, and it will come more with more practice. With more practice, you will see these different avenues. So this is all that I have in the session. Now I have a set of few questions for you to try out. So I will ask each of you to try it out and at least try to see whether you can quickly solve question number E, which is 11 into 37, and question number F, which is 15 into 25, E and F.
Right, students. So please start attempting question E and F. Question E is 11 into 37 using the method for multiplying digits with 11 that Mr. Debapriya just mentioned. And F is 15 into 25 using the method that Mr. Debapriya just taught about how to get multiplications of numbers with 15. So when you type in your answers in the comment box, please do mention E and F against the number, whatever you are writing, so that we can know which answer you are referring to. All right. So a lot of students are typing in for A, B, C also. Answer for A is 36. All right. Tanvi and Sai Prada and Zulfair, you're right. But please type in your responses for E and F. All right. Uh, okay, students. So while there's a student who's asking that we did not study the table for 12, I think we'll just take this question after this exercise. While the method will be the same, but Mr. Debapriya will just address this question after this. So Sunil Budni is saying 11 into 37 is 407, 15 into 25 is 375.
Yes, correct.
Uh, all right, Ajit Tiwari is saying E is 407. Sindhu is saying F is 375. Harminder is saying 407. Sajita is saying 407. Zubeda is saying F is 375. So a lot of students are now typing in almost like more than like 200-300 responses we've already received for these
Yeah,
questions.
yeah. So what are the different questions that they have in mind? I'll be happy to answer.
Sure, students. So while you are mentioning your responses to these questions in the comment box, please do mention along with the options what you're responding against, as well as please do type in your questions. So there was one student who just asked Mr. Depri, who just asked, we did not study the table for 12 or how to calculate, the multiples of 12 in this class. So can you please quickly
Yeah,
touch base with that?
I have told you how to do it. So the way we have computed the table for 13, so the same way you can compute the table for 12 as well. So 12 is basically 10 plus 2. So 10 multiplied with 3 is 30, and 2 multiplied with 3 is 6. So then you have to go for adding 30 with 6. So 30 plus 6 is 36. So even if you have not studied the table of 12, you can, even if you don't remember, even if you don't know, but the similar way you can compute 3 multiplied by 12. The same thing holds for 5 into 46. Nobody will ask you for remembering table of 46. So how will you compute? You will compute in the same way. So 46 is equal to 40 plus 6. And then 40 multiplied by 5 is how much? It's 200. And 6 multiplied by 5 is 30. So 200 plus 30 is 30, 230. So it's 230. So this is how you have to compute it mentally. Then same applies for 9 into 23. So 20 plus 3. So 20 multiplied by 9 is 180. And 3 multiplied by 9 is 27. So 180 to be added with 27. So 180 plus 20 is 200. And then you have leftover 7. So 207. So 207 is the answer. So this is how you should start thinking of computing all these things mentally. And more you do it, you will be better in doing it more quickly.
Right. Thank you so much, Mr. Debapriya. So, while a lot of students are typing in the right answers, there are students. So, let's say, for instance, Kinchuti mentioned 372 for F, answer of F. There is Nafis Sathu who mentioned 380. Just like to point out that, please do check your answers. It's okay to be wrong, when you're trying for the first time, but please do try again. And as I think Mr. Depriya was saying, do try out these answers against the normal way in which you multiply to see if it's right or wrong.
Yeah. Yes.
Small calculation errors can quickly be avoided with practice. Right.
Yeah. Small calculation errors can be avoided quickly with practice.
Right. And also, students, while we proceed with some more questions, there is a feedback form which is pinned at the top of the comment box. Please do take just 1 minute, it'll not even take 1 minute. Do give in your feedback for this session. It really helps us to improve the future sessions that we have planned for you. So, anything that you feel, if it's great, please mention. If you see there is any area of improvement, please do mention. We'll make sure that we improvise as per the feedback given by you. By the way, Mr. Depriya, like a lot of students have typed in the right answers for each of the A to F exercises given in front of the screen right now. So, which is great. I
Okay.
mean,
I'm very happy
like,
to see that they have been able to apply it.
yes. There is Aradhya, fourth class, Golden Valley Public School. Aradhya, please do type in the full question, right? Arnav is saying he's really inspired by your mental maths skills. So Arnav is asking, sir, who taught you maths? Who was your maths teacher?
Okay. So my maths teacher initially was my father. Uh, so I studied maths from him at a very initial age, and then somehow throughout the process he uh, took care that I practice problems more, and he took care of these particular aspects very diligently throughout years. So I have opportunity to solve the same problem in a particular class time and again, and this has helped me in taking a look into the same problem in different angles, and that has helped me also to ask different questions while trying to solve a problem. It's not just being able to hit the answer and just making an hooray out of it that my problem is solved and it's matching with the answers given. Basically, that's not the end goal. The end goal should be that throughout the process, have you learned each and every step? Throughout the process, have you learned why you have done this step after this step? So that's very important, and he insisted on that, and that's how possibly I have started to think in terms of mathematics.
That's really inspiring and great to hear. We also have another question from Anish from SBS Model High School. He's asking, how can we create deep interest in mathematics? Seems like you have a very good interest and you're very good at it. So how can we become like you?
Basically, deep interest in mathematics, you can you cannot just develop in only one day. It will take years for you to develop that interest. But to start with, you have to conceive each and every concept very diligently, very religiously. You have to go by whatever your parents, your teachers are asking you to solve, and what they are trying you to make understand about a particular topic. You should try to follow that, and not only just following it, you should think about it of your own. And if you have any doubt, if you have any question, you should ask questions, and don't feel shy asking questions to your elders, because that is how you will learn. So you have to build that courage, or that feel within yourself, that if I don't know it, there is nothing wrong. If I have to know it, so I have to ask for it. So you have to ask for it, and you will automatically get to learn. And the more you will know about a particular top topic, it is not enough. You have to be master about a particular topic, and that will come only through sheer practice, more practice, vigorous practice. And then more you do that, automatically your foundation, your basics will be strong. And the moment your basics will be strong, the forward looking classes, or the classes that will follow next, will be easier for you, and you will not feel that difficulty. So that's how you automatically will start to see different applicabilities, different concepts from different angles. You have developed over years out of the box thinking. You have developed over years the different ways of looking into a problem, different ways of solving a particular problem. uh, so that will automatically inculcate a deep interest about mathematics in the subject. And it's not all that. Whenever you have time, try to play with numbers. Whenever you have time, try to see the recreational aspects of mathematics. There are many recreational aspects of mathematics, and that will help you feel better about mathematics. That will help you to feel confident about mathematics. So that's what you can follow to craft your own journey.
Sure, Deb, that is really, really helpful. And while you were saying, we've been receiving like hundreds of responses from students who are really, really grateful to you. And so, for instance, Ishal Siraj is saying this class was so interesting and fun. I'm little lazy to do multiplication, but now I understand how to do this. Thank you so much. And a lot of people are saying this was eye-opening and this is going to be really helpful. So, and by the way, we have students from across the country. I mean, can't even name. There's so many cities these students are from, so many different schools. Thank you so much, Dave. I think this was extremely helpful to the students. While we would have loved
Yeah.
to continue talking to you for hours, we've really run out of time. Thank you so much, Mr. Depriya, for sharing your journey and tips on mental maths. I'm sure this will
Yeah.
go a long way to help acquire one of the most important skills for thousands of students listening to you today. So, thank you once again on behalf of all the students who joined us today for the session, and hope to see
Yeah.
you very soon. Students, quick two things. One, please, please, please do fill in the feedback form. And second, we will have the next session for all of you with Mr. Depriyo on January 23rd. So January 23rd, the next Sunday at 11 a.m. So please do make a note of it, and we hope to see all of you on January 23rd at 11 a.m. Thank you once again, Mr. Depriya. Signing off from
Yeah.
today's
Thank you.
session.
Yeah.
Goodbye,
Thank you.
everyone. Take care and have a very nice day.